So I got cut off a little bit, and so I'm going to pick up number 6 where I sort of left off, where 50, the exterior angle, was half the difference of the arcs. Simplified, then I multiply both sides by 2 and get 100 equals 360 minus 2x. And then solving for x, I'm going to add 2x to both sides and subtract 100 from both sides at the same time. So 2x equals 260. So x equals 130. If x equals 130, then 360 minus 360 minus x equals 230. So f is equal to 130 and g is equal to 230. And just to check, this exterior angle should be half the difference. So 230 minus 130 is 100, and half of that is 50. Number 7. This angle created with this tangent and this chord is on the circle. Angles that are created on the circle are half their intercepted arc. So this angle right here is half of 140. So h equals 70. Number 8. Continuing with the idea of inscribed angles being half of their intercepted arc, J is inscribed on the arc 120 plus 60. And just to make sure I explain myself a little, this inscribed angle is half the intercepted arc. It acts very similarly to an angle that is on a circle created by a tangent and a chord. This angle is half of this intercepted arc, similarly to the way inscribed angles behave, as this inscribed angle is half of the intercepted arc of 120 plus 60. So J is equal to 1/2 of 120 plus 60, which is 180, so J is equal to 90 degrees. Well, we could just say right away that L is equal to 90, since opposite angles in a quadrilateral inscribed in the circle are supplementary. We could say that L is 90, and it is. You can also see it, however, when you look at the inscribed arc that it's on. This inscribed angle of L is on the arc 180, 100 plus 80, so it is also 90. I'll leave you to find K. It's an angle inscribed on the arc 120 plus 100, and I, which is the inscribed angle on the arc 60 plus 80. Number 9. Inscribed angle here is half the measure of the arc here. So for number 9, m plus 3 is equal to half of its inscribed arc, which is m plus 20. M plus 3 is equal to half m plus 20. One equation, one unknown, we can solve. I'll multiply both sides by 2. That's 2 times m plus 3, the quantity, equal to m plus 20. Multiplying both sides by 2 to clear the fraction. Distributing the 2 gives 2m plus 6 equal to m plus 20. Solving for m gives m equals 14. I'm just going to check this answer. If I put 14 in for m, will this value be half of this value? 14 plus 3 is 17. M plus 20, that's 34. And yes, 17 is half of 34. So m equals 14. Number 10. Here is an inscribed angle on a semicircle. So right away, we know that n, because it's inscribed on a semicircle, is equal to 90 degrees. This angle is equal to 90 degrees. How do we find the length of this side? Well, it's a 90-degree it's a right triangle. So sometimes we can use the Pythagorean theorem, but we don't have the length of this short leg here. Ah, I just gave something away. If we have an arc here of 60, then the inscribed angle on that arc is 30. So this is a 30, 60, 90 degree triangle. And because it's a 30, 60, 90, we can find the short leg here by using the length of the long leg. Here's a right triangle. It's 30, 60, 90. We know the long leg. The short leg is equal to the long leg divided by rad 3. It's equal to 9 divided by rad 3. To rationalize that, we'll multiply top and bottom by rad 3. We get 9 rad 3 over 3. Simplifying that gives 3 rad 3. When we are trying to find a side of a 30, 60, 90, you have to find the short side first. 3 rad 3. Now I just double it, and that will be P. P will be 6 rad 3. 30, 60, 90 inscribed in a circle. And we discovered it by not only recognizing that this was 90 degrees, but that because this arc was 60, this angle is 30. So we have a 30, 90, this has to be 60. And so we can use our knowledge of 30, 60, 90 special right triangles to find the length of the short side first, and then the length of the hypotenuse. Number 11. A chord of a circle is 2 units away from the center, and the radius is 3. Find the length of the chord. Well, we'll draw a circle. Here's the center. Here's a chord. And the chord is 2 units away from the center. Now notice I put the perpendicular mark here because distance is the perpendicular distance between a point and a line or line segment. This is 2 units. I'm going to draw a radius. I'm going to connect the radius from one end of the chord to the center, so that is 3. Well, we have a right triangle here. We can use the Pythagorean theorem to find the length of that piece of the chord. 2 squared plus, say, x squared equals 3 squared. X squared equals 3 squared minus 2 squared, that's 5. So x squared equals 5, which means that x equals the square root of 5. This little piece equals the square root of 5. If that little piece equals the square root of 5, then the whole chord is double that. So the whole chord is 2 square root of 5. But how do we find B? Finding the measure of this arc. How do we find the measure of this arc? Well, remember we use triangles a lot when we're trying to find things in circles or prove ideas in circles. So I'm going to make this line here. That does give me a triangle, but more importantly, it gives me a central angle. This central angle will be equal to the measure of this arc. Central angles are equal to the measures of their arcs. How do I find this central angle? Well, the hint says to use trig. I'm going to find the measure of this angle right here using trig in this right triangle. Then I'm going to double it, and that will give me the measure of the central angle, and then I can find the measure of the arc. For this angle, I'm going to try to use the 2 and the 3 to avoid the radical sign, just makes it easier for me. The relationship between this side and this side is cosine. Cosine of x uses the adjacent side over the hypotenuse. So the cosine of this angle right here, x, is just a second. Oops. Cosine of this angle right here is equal to the adjacent side over the hypotenuse. To find x, we use the inverse. Cosine inverse of 2 over 3 equals x. If we want to find the whole angle, thus the whole arc, we'll just multiply that by 2. So the exact answer is 2 cosine -1, or the inverse, 2, 3. That's the exact answer for 11B. And then putting that in your calculator will give us the approximate answer. Cosine inverse of 2 divided by 3 times 2 equals 96.38 degrees. And that's the answer for number 11. Make sure you see that. You can pause your video. Number 12, 13, and 14 require the formula or the proportion that relates the length of an arc to its central angle. Number 12. L equals the central angle over 360 times 2 pi r, or the arc measure over 360 times 2 pi r. So number 12 says, find the exact length of an arc that is 60 degrees in a circle whose radius is 12. Length equals 60 degrees over 360 times 2 pi times 12. We'll simplify this equation here. L equals, I can divide those both by 10, which gives 6 over 36, and then divide them both by 6, which gives 1 over 6 times 2 times 12 is 24 pi. 1 over 6 times 24 pi. Now, if it helps, extend that line to remember that this is in the numerator. Well, these can also cancel. 6 goes into 6 once, 6 goes into 24 4 times. So my answer is 4 pi. That is the length of the arc in a circle whose radius is 12 units. For numbers 13 and 14, to find some measure other than the length of the arc, I always recommend using the proportion. The portion of the circle over the entire circumference equal to a portion of the circle's measure over 360 degrees. The length is given to us as 20 centimeters, and that is to 2 pi times 12. And we're looking for the degree measure of x. Now here it does not say exact or approximate. We're going to find the exact first, and then I'll let you find the approximate. So to find the exact, I'm going to simplify this and this before I cross multiply. This is a proportion, so we'll cross multiply to solve. This can be canceled with this, so I get 10 over pi times 12. I can divide that by 2, that's 5. Divide that by 2, that's 6. I get 5 over 6 pi equals x over 360. Now I'll cross multiply. 5 times 360 equals 6 pi times x. 5 times 360 is 1800, and that equals 6 pi x. And I'll divide both sides now by 6 pi. So x equals, 6 goes into 1800 300 times. X equals 300 over pi degrees. That's the exact answer. And I'll let you put that into your calculator and round it to the nearest hundredth. Number 14, we'll use the proportion again. L over the whole circumference equals x over the whole measure in degrees. We're asked to find the radius, and we're given the length of 20 over 2 pi, and a radius we don't know. The angle degree is 12 over 360. So I can simplify here before I cross multiply. This would be 10, this would be 1. I get 10 over pi times r equals, and I can simplify this side too. 12 goes into this once, 12 goes into this 30 times. Cross multiplying to solve gives 300 equals pi times r. So r is going to be equal to 300 divided by pi. And that's the exact, and it turns out it's the same answer as we got for 13. And then you can simplify that with your calculator. One last idea before I go is when you're finding the definition of these words, the definition of pi is the circumference of a circle divided by the diameter. If you want to write it in words, you could say it in words, the circumference divided by the measure of the diameter, or the diameter. We're just going to assume we're talking about the measure here. The key thing to remember here is pi is equal to circumference over diameter. It doesn't matter how big the circle is or how small it is. The circumference of the circle in relationship to the diameter will always be pi. I hope you have a great weekend, and I hope this was helpful. If you notice any mathematical mistakes, please comment in the video below, and I'll see you on Monday.